All right, folks, today we are doing worksheet 4. This is one of those long ones with 20 questions. So what I would suggest you do is, if you need help on a particular question, just skip immediately to that question. Okay? All right, so our first question is, what volume would be occupied by some number of molecules with carbon dioxide at STP? So let's think about this for a second. We are given molecules, and we're trying to get to volume, which is liters. So we have to go from molecules to moles to liters, because we do not know how to go directly to liters from molecules. Okay, so let's go ahead and do that. We have two conversion factors we have to use, and because grams are not mentioned, we don't have to calculate anything. So we can just start with 9.45 times 10 to the 24th molecules. And we are going to convert from molecules to moles. And then from moles, we have to convert to liters. Dimensional analysis. All this is dimensional analysis. All right. So the number of molecules is 6.02 times 10 to the 23rd in 1 mole. And then in 1 mole, there are 22.4 liters. All right, so you have to take this number on top. You have to multiply by 22.4. You have to divide by 6.02 times 10 to the 23rd. Again, assuming you're using your calculator properly, as I showed you in the podcast, then you are going to come up with 352 liters. All right, how many calcium atoms would be in a 100-gram sample of calcium metal? And they have to be kind of, this one's pretty easy, but then your answer is going to be kind of strange. All right, we're talking about atoms, and we're going to grams. So that means we have to look at grams, and we're talking about calcium. So we look up calcium on the periodic table, and calcium is 40.08 grams per mole. Okay, so it looks like we've got about 2.5 here as our answer. So let's go and actually work it out. 2.5 moles, and then we have to figure out our atoms. So let's go and do this. So we start with 100 grams. Now, the thing that's tricky about this one is there's only one decimal place there. I'm sorry, there's only one digit of precision there. So our answer, when we're all done, is only going to have one digit of precision. I have to go from grams of calcium to moles of calcium. And from moles of calcium, I have to go to atoms of calcium. Right, well, my grams is 40.08 in 1 mole, and my 1 mole is in 6.02 times 10 to the 23rd atoms. Now, you should know that number by now, right? And when I work that number out, I get 1.50 actually times 10 to the 24th, but I can only have one significant figure. And 1.50 rounds to 2 times 10 to the 24th atoms. Sorry, guys, I don't like it either, but it's important that we look at sig figs. So if you came out with 1.50 and you stopped there, I understand why you did that. That's okay. Just make sure that here's a sig fig issue. Okay. All right. How many grams are in this many atoms of zinc metal? So the first thing we have to do is figure out how much zinc weighs, because we have grams involved. Because we have to go from atoms to moles to grams. So as you think about it, you're going from atoms to moles to grams. So we have 5.6 times 10 to the 23rd atoms. And we have to convert from atoms to moles. And then we have to convert from moles to grams. Now, our 6.02 times 10 to the 23rd is our number of atoms in 1 mole. In 1 mole, we have to look at our periodic table to figure out that zinc weighs 65.39 grams per mole. Now we go into the math, and we come up with a total of 61 grams. And you'll notice I have 2 sig figs in my answer because I have 2 sig figs in my problem. All right, looking at number 4, calculate the number of molecules in 4.56 grams of lead nitrate. So I have grams again, so I have to figure out how much lead nitrate weighs, which means I have to figure out what lead nitrate is. Well, lead is Pb, and nitrate is NO3, and nitrate has a -1 charge, and lead has a 2+ charge. When they crisscross, I need 2 nitrates, so I have to put the 2 over there. So let me figure out first how much lead nitrate weighs. Well, the lead is 207.2. And I have to add that to nitrogen, which is 14.007, but I've got 2 of them. I have to multiply that out, plus oxygen, and that's 15.999, but I have 6 of them. Right? So my answer here is going to be, for the mass, 331.2 grams per mole of PbNO3. All right. So, let's do my problem. My problem starts with 4.6 grams. Right? So we're going to start with 4.6 grams, 4.56 grams of lead nitrate. And I'm going to convert from grams of lead nitrate to moles of lead nitrate. And then from moles of lead nitrate, I can go to what I want to find out, which is molecules of lead nitrate. Molecules of lead nitrate. Well, I know that there are 6.02 times 10 to the 23rd molecules in 1 mole. And the 1 mole is a certain number of grams, and I've calculated that gram up here, so it's 331.2 grams. When I multiply and divide everything, I come up with 8.29 times 10 to the 21 molecules. Okay, let's go on to number 5. Calculate the number of liters in 3.25 grams of ammonia, also known as nitrogen trihydride at STP. Well, nitrogen trihydride is NH3, that's ammonia, and that's 14.007 plus 1.0079, and there are 3 hydrogens, so I have to multiply that out first. Right. That is going to give me an atomic mass of 17.031 grams for NH3, for 1 mole of NH3. So let's go and do the problem that I have. I have 3.25 grams of NH3, and I'm going to convert from grams of NH3 to moles of NH3. And then I'm going to convert from moles of NH3 to liters of NH3. Because that's what I'm trying to figure out is liters. Well, liters, there are 22.4 liters in 1 mole. That's easy. And for every mole, I figured out that there are 17.031 grams of NH3 in 1 mole. So when I actually multiply this all out, I get 4.27 liters of NH3. Okay, here we have a question where we are calculating liters, and we're starting with molecules. So you'll notice we don't have to worry about grams here. So we start with 5.43 times 10 to the 25th, and that's molecules. And what I'm then doing is converting from molecules to moles, and then I'm converting from moles to liters. And my moles to liters conversion is always 22.4 liters in 1 mole at standard temperature and pressure. And there's 6.02 times 10 to the 23rd molecules in 1 mole. So when I multiply all this out and divide all this out, I get 2020 liters. Now again, notice I had 3 sig figs in my problem. I've got 3 sig figs in my answer. That's where that came from, because I did have to round. Okay, number 7. Calculate the number of grams in 3.54 liters of carbon dioxide. Right, well, the first thing is that carbon dioxide is something very common. So I don't know if I'm going to use it again in this podcast, but I'll do it quickly. Carbon is 12.011. Oxygen is 15.999. And there are 2 of them. When you add that up, you get 44.009. All right, so I'm starting with 3.54 liters of carbon dioxide gas. And we're going to get rid of liters of carbon dioxide gas and go to moles. And then from moles, we're going to go to, well, the thing we want are grams of carbon dioxide gas. I know that there are 22.4 liters in 1 mole. And 1 mole, when I go to grams, according to what we just figured out, is 44.009 grams. When I do my math on this problem, I get 6.95 grams of carbon dioxide gas. Okay, that's the end of page 1. 2 pages to go. All right. The number of grams in molecules. So I'm converting from molecules to moles to grams. So I have to figure out how many grams I have in this silly thing over here. So let's figure out what we have. We have carbon, which is 12.011, and I have 2 of them. I've got 1 there and 1 there. So I've got 2 of them. And hydrogen is 1.0079, and I've got 3 plus 2 plus 1, that's a total of 6 of them. And I do have an oxygen thrown in, which is 15.999, and I have 1 of them. All right, when I multiply all those out and come up with an answer, I come up with 46.068 grams per mole. All right, so now I can actually do my problem. My problem, I'm given 9.7 times 10 to the 22nd molecules. And I have to get rid of molecules and go to moles. Yes, to moles. And then I have to go from moles to, what am I going to? I'm probably going to grams, right? I'm going to grams, okay. So 1 mole is 6.02 times 10 to the 23rd. My grams is 46.068. And my moles is 1. So as I go through this problem and figure out my answer is going to be 7.4. Notice only 2 sig figs because that's what was given to me in the problem. 7.4 grams is my answer of, what is it, whatever this stuff is. Okay, CH3CH2OH. All right, look at number 9. Well, we just did carbon dioxide. I know that carbon dioxide weighs 44.009 grams per mole. Go back to number 7 if you want to check that out. I think it was number 7. And we're starting with 64.8 liters. So we start with 64.8 liters. Get rid of liters, we put liters on the bottom. We go to moles. We're always going to moles in the middle. And then from moles, the question is, what do we want to go to? And it's asking for grams, so we're going to go to grams. And there are 44.009 grams in 1 mole of carbon dioxide. And for every mole, there are 22.4 liters at standard temperature and pressure. So I do this math, and I come up with 127 grams of CO2. All right, calculate the number of molecules in so many grams. So again, we have the 44.009. We already know that that's the mass of carbon dioxide per mole. So I don't have to calculate that again. So I have 64.8 grams of carbon dioxide gas. I'm going to divide that by 44.009 grams of carbon dioxide gas and go to 1 mole. And then from 1 mole, I'm going to go to molecules, which is 6.02 times 10 to the 23rd molecules. When I multiply all that out, I get 8.86 times 10 to the 23rd molecules. All right, number 11. How many liters of carbon dioxide gas are in 2.96 molecules? Guys, we're going to assume this is at STP. On your worksheet, it says at STP. I forgot to put it here. So we have molecules and we have liters. So we know those conversion factors, so we can immediately jump right into solving the problem. So we start with the information we're given, which is 2.98 times 10 to the 23rd molecules. So I have to convert from molecules to moles. And then I have to convert from moles to liters. And I know that they're 22.4 liters in 1 mole. And 1 mole is 6.02 times 10 to the 23rd molecules. Right? When I actually multiply this out, I get 11.1 liters. And this is of CO2 gas. All right. Determine the number of molecules of carbon dioxide gas in 8.44 liters at STP. Well, notice this has gone from carbon dioxide to carbon monoxide, but because it's just a gas, we don't care. We only care if we have to worry about the mass. We don't have to worry about the mass. So we're going to start with 8.44 liters, and we're going to convert from liters to moles, and then we're going to convert from moles to molecules. Right? And we know that there are 22.4 liters in 1 mole, and 1 mole is 6.02 times 10 to the 23rd molecules. So when I do the math here, I'm going to come up with 2.27 times 10 to the 23rd molecules. And this is carbon monoxide. All right. Now determine the number of grams of carbon monoxide gas in 8.44 liters. Well, now I do have to calculate the mass of carbon monoxide, which is Cl, which is 12.011 plus 15.999, which gives me as an answer 28.01, actually 010 grams per mole. So I start with 8.44 liters, and I convert liters to moles, and then I convert moles to grams. And there are 22.4 liters in 1 mole, and 1 mole is the same as 28.010 grams of carbon monoxide. When I multiply this out, I get 10.6 grams of carbon monoxide, which is deadly. All right, number 14. How many grams of carbon monoxide gas are in 8 point whatever? Well, we already know that carbon monoxide gas, because we just figured this out, carbon monoxide gas weighs 28.01 grams per mole. So I can immediately start working on the problem. 8.91 times 10 to the 23rd molecules. And I have to get rid of molecules and go to moles. And then I have to go from moles, and I have to go to grams, because that's what it's asking for. And I know that there are 28.01 grams in 1 mole, and 1 mole is 6.02 times 10 to the 23rd molecules. So when I multiply this out, I'm going to get 41.5 grams of carbon monoxide. Okay. On to page 3. Yeehaw, last set. Okay. Determine the number of grams of nitrogen gas. Nitrogen gas is N2. So since we're dealing with grams, we have to look at N2, which is 14.007, and we have to multiply by 2. That's 28.014 grams per mole of N2. So we're starting with 8.64 liters of N2. And we have to go from liters to moles, and then moles to grams. And for every mole, there are 22.4 liters. And for every mole of nitrogen gas, it's 28.014 grams in 1 mole. I multiply this out, and I come up with 10.8 grams of N2 gas. Right, number 16. Determine the number of molecules of nitrogen gas in 8.64 grams. Well, we just figured out the mass. So we don't need to do that again. So we're starting with 8.64 grams of N2 gas. And we just figured out that N2 gas weighs 28.014 grams in 1 mole. And now we can get rid of moles again, and we can go to molecules. And that's 6.02 times 10 to the 23rd. That Avogadro's number just keeps coming up. And our answer is going to be 1.86 times 10 to the 23rd molecules of N2 gas. On to number 17. We have liters, we have molecules, don't need to worry about mass. So we have, let's start with what we have, 9.82 times 10 to the 24th molecules. And we are going to get rid of molecules. And what are we going to go to? Of course, we go to every time is moles. We always have to go to moles. And then from moles, we have to go to, in this case, liters. Moles is always 1. Liters is 22.4. Molecules is 6.02 times 10 to the 23rd. Okay. When we multiply this whole thing out, we get 365 liters. It happens to be of nitrogen gas. Okay, last 3 problems. Determine the number of atoms of neon gas in 48 liters. All right, well, we don't have grams to worry about, so we can immediately start the problem. 48.84 liters. And we want to go from liters. What are we going to go to? We're going to get rid of liters, go to moles. Then we get rid of moles, and we go to atoms. Well, our moles are always 1. Our liters are 22.4 because we're at standard temperature and pressure. And our atoms are 6.02 times 10 to the 23rd. So when I do all of my math, I come up with 1.313 times 10 to the 24th. All right, and what is that? Those are molecules. Those are actually atoms of neon. All right, number 19. Grams of neon, liters, we have to figure out grams of neon. All we have to do for this is look on the periodic table to see what neon is, right? And neon weighs 20.180 grams. All right, so we start out with 48.44 liters. Now we have to convert from liters, and we always convert from liters into moles. And then from moles we can convert to whatever we want, and in this case moles is going to grams of neon gas. So we have 22.4 liters in a mole. That's volume. And for 1 mole we have its mass is 20.180 because we looked that up in the periodic table. When we actually do our math for 19, we come up with 43.64 grams of neon. Okay, last problem. How many grams of neon gas, while we're still using that 20.180, are in 2.74 times 10 to the 24th atoms? So 2.74 times 10 to the 24th. Those are atoms. And we're going to go from atoms to moles. Then we're going to go from moles, we're going to hop over to grams. And we know that for every mole, there are always 6.02 times 10 to the 23rd things in it. And for 1 mole, we had to figure out the grams, so we said we just looked that up on the periodic table, and that's 20.180. We multiply this whole thing out, and we get 91.8 grams of neon. All right, folks, that was a lot of work, all right? But you have to make sure you know how to do it. And if you have questions, come see me. Otherwise, I'll see you in class. Have a good day. Bye-bye.